All right. Uh, Sorry guys, I had to join back. I got kicked out for some reason. Thanks everyone for joining. So I hope today we will be um, doing a day one. We had a day zero yesterday with respect to um, our session on Palo Alto. Is there anyone who has joined new today from yesterday who has missed your yesterday's session?
Hi Azad, I have joined today as a new.
Okay. Yeah, anyways, we will be having a recall session on yesterday. We will be just had a very basic session as to how did we compare your routers with the firewalls, uh,
Okay,
the legacy firewalls with versus routers versus your next gen firewalls that we're supposed to learn in this course uh,
okay,
as a product Palo Alto. So, but just give you a review or overview. On top of that, I think you should have the recordings that you can go through as we progress along the session for yesterday as well. So, um, okay, let me share my screen. So let me first walk you through the session description as to what we are going to look at today, before which we will be talking about what did we talk about yesterday, since a few people are in new today. I'll just quickly take about 5 to 10 minutes on this one and then get started with today's session. So today's session again, we will be talking a bit about the firewall's packet flow, as to how the packet travels through the firewall. So I'll be walking you through the process by taking an example of a flow chart, a flow diagram, which is available on the official website. So just give me 1 second. Can everyone see my screen?
yes, yes.
Okay.
Yes, sir.
All right. Okay, so yesterday's session, we had discussed about, as I mentioned, it was the comparison between routers versus firewalls versus legacy firewalls versus your next-gen firewall. So we gave you some key points as to how did we compare the three devices and why we moved from routers or legacy firewalls to next-gen firewalls, and what are the features now. We described a few features as to what next-gen firewalls can offer and how it is useful for us with the enterprise infrastructure. So we just gave a brief introduction about it to start with. Just allow me one moment, guys. I'm sorry. All right. I'm sorry. My pen was misbehaving. I was not able to connect properly. All right. So yesterday's discussion was the comparison between a router versus a legacy firewall versus next-gen firewall, right? So I'll just write a tabulation here as to what did we discuss about. so that we can move forward quickly. So when we said router, we said it's a layer 3 device. It can do routing. Additionally, we could do ACL, where it could do filtering of traffic. It could only do filtering of traffic. So we shouldn't misunderstand accessing or configuring access list as a security mechanism. It was a security mechanism earlier, but right now, with the emergence of next-gen firewalls, it is no more a security mechanism. It is nothing but a filtering. So we do just IP filtering here with routers, along with routing and route manipulation, path manipulation, right? These are the only two stuff that your routers do, and they are not capable of doing application. They are not application aware devices, which means they won't be able to identify which application the user is accessing. For example, if he's accessing a Facebook or YouTube, etc., he they only see them based on port numbers, whether they're accessing a port 443 or 80 or 22, etc. They don't look at the application, or they are not capable of identifying the application. Hence, they don't do application security. The same applies with your legacy firewall as well, but your legacy firewall, on the other hand, it does everything that your router does. It's a layer 3 device, it does routing, path manipulation, it also does access list, but it looks up to layer 4 of OSI model, where it also deals with protocols and port numbers. It adds these two parameters as a filtering mechanism inside it. And also, we said that they are stateful devices, stateful firewalls, meaning when an inside user initiates a traffic, when a user initiates a traffic, it's enough for you to allow the access list, allow the policy this way towards the server that we are accessing. The return traffic, the response from the server is automatically allowed, right? We discussed this yesterday, right? So this is the only main reason why, because of this stateful inspection and the capability of having the inspection done up to layer 4 in the protocol and port level, the routers are very slowly replaced with legacy firewalls earlier. And then we are into next-gen firewalls for past 10 years or more, where we inspect the traffic up to layer 7. Layer 7, as you know, it's an application layer. So it doesn't mean that we don't inspect layer 4 or layer 3. We do inspect layer 4, layer 3 as well. Transport and network layer. Of course, your next-gen firewalls are also layer 3 devices. They do routing, they do path manipulation, they do filtering. But the filtering is more advanced filtering, where we filter the traffic not just based on IP address, protocols, port numbers, but also based on applications, URLs, users, and much more. Right? So we will be able to integrate your. We also saw that we will be able to integrate our Active Directory into our firewall, and then we'll be able to identify which exact user of your domain, of your company's domain, is accessing what. Which application is he accessing? Is he accessing Facebook or is he accessing YouTube? Which URL he's accessing? If he's going and accessing a website, what is the URL he's accessing? Whether it's a safe URL that he's accessing according to Palo Alto networks. Palo Alto always categorizes the information that the user accesses, may it be application or the URLs. So is it safe that the user is accessing? So just not this, but there's much more to what it does related to security. We discussed about a lot of features that the Palo Alto can offer. We discussed about application ID, where identifying the application. The user is accessing the end application, not just if it is Facebook or YouTube. If it's Facebook, whether he's accessing Facebook chat or Facebook video or Facebook base, the end application will be identified by app ID, then user ID. So we'll be able to integrate our Active Directory to our firewall, and we'll be able to get the information about which user is accessing which resource through the firewall. Thereby, we'll be able to do some advanced filtering based on the users and user groups of your organization. And also, with respect to logging, it will log the traffic based on the username. And we also saw antivirus, anti-spyware, anti-malware profiles that we can create, where we can mention if the traffic is identified to be a threat based on any of these malware or spyware or viruses, what actions we could take, whether we could restrict the user, drop him, block him, etc. So we discussed about a lot of features that the firewall could offer. Based on each of the features, we'll be having an extended session later on as we move along with the session, right? So we just discussed yesterday about a definition about what they can do, or what the feature is about. And we also discussed about a feature called wildfire, the last feature that we discussed yesterday. This is the feature to mitigate zero-day attacks in your network. So we didn't go deep into this one as again yesterday intentionally, as it was the day zero. I will be talking about this extensively on how exactly this works when we get to this. Right, this was a brief introduction about yesterday as to what we discussed. Right, any questions, people who have joined new, so that we can get along forward with the next one?
No, all good, all good.
Okay, thanks. Okay, so as I said, the agenda for today would be on talking something basics again about Palo Alto. So I thought I would talk about the different ways of zero-day configuration. So how do you get your firewall ready for you to, configure them or get into the network? Zero-day deployment. So when you get your firewall new, what exactly you should do? So people who are into operations, they don't really have get the exposure basically to deploy a firewall. Now, probably they can configure a firewall in their lab and understand how the configuration works, but no, it's pretty hard for people who are in operations who don't get to actually deploy the firewall. It most probably will be done by the architects or the implementation engineers. If you're not part of the team, so you should probably be aware of how the zero-day deployment works. There are different ways of actually deploying your firewall to get access to the firewall. More often than not, you will be remotely located. You will not be at the location where your firewall is going to be configured and deployed, right? So how do you basically get your firewall into the network? So that's something that we'll be talking about, and then we'll be moving forward with understanding some basic information about the firewall as to how the packet flow works. So with respect to zero-day deployment, you get your firewall out of the box. There are two ways you could deploy a firewall and get access to them. One, as you know, you can get the console with the help of local IT to the local IT's computer and ask him to share. You will be located somewhere remotely and ask him to share the screen, and then you could try to configure the firewall. But what exactly will you be configuring? Allow me a second, yes. Sorry. Sorry, I had to seal my door. I thought you guys would hear some background noise. So, yeah. So your console cable would be connected to the firewall, and your local IT would be sharing your screen. You'd be getting access to the firewall, but you probably would be getting your access through CLI because console is always CLI, as you know. But the firewall, the Palo Alto Firewall, 99% will be dealt with in GUI. So it's a GUI based device. You should understand that. So you can do pretty much everything in GUI, CLI, but the configurations are better done, and the view or the look and feel would be better if you do it through GUI. Probably for troubleshooting, we will be going over the CLI side of it in our session, but most of the configurations, both in production and in our session, will be dealt with in GUI. So when you take console access, you will only have CLI based access to the firewall. So you probably will take the console access and you will have the CLI access to the firewall. You will have to configure an IP address to the firewall. So by default, your firewall comes with the default IP address of 192.168.1.1.
Sir, one question, sir.
Yeah.
Sir, how to find out, sir, how high CPU utilization, high bandwidth utilization, sir?
On the firewall,
Palo
you mean
Alto.
you want to identify the CPU and bandwidth utilization
Yes, sir.
of your file. Yeah, there will be an option. There is a widget that is available that you can take a look on the dashboard section. I will probably show you when we log into the firewall. Probably today. I'm not sure if we will be handling it today, but I'll definitely show you that. I'll keep mark this down. That's part of the walkthrough, GUI walkthrough. I will definitely be attending that.
Because that question arises, no, sir, that user using uh, many user are using much bandwidth.
Mhm.
So that's why I asked the question.
Definitely. I mean, that's a good question, but it's sort of away from the context we are discussing right now. But I'll definitely attend that question when we get to the lab session, when we actually log into the firewall and check few things. I will be attending that question and answering you.
Mm,
Yeah.
fine, sir. Thank
There
you.
is a place where you check your CPU utilization. CPU utilization basically on is how the firewall load is, how much load the firewall is receiving. Bandwidth utilization is basically how much your ISP link is being utilized, right? So that's usually the same way that you can to check them based on QoS, based on different mechanism. You can check with your ISP as to how much of bandwidth is being utilized from their side, so they will let us know if the bandwidth is 100.
Sir, plus one thing, sir, which user using more bandwidth, sir? Because the production time ticket arise CPU and bandwidth utilization. So we have to find the user, which user is downloading more files. So that's my question.
Yeah. First of all, if you identify that your bandwidth is being choked from your ISP, if your ISP says that the bandwidth is probably 100 Mbps and you are overutilizing the bandwidth, then you will have a place where you could come and check based on the user's IP address or username. You'll be able to see which application is he using and what is he downloading, how much of data inbound, outbound he is downloading or uploading. Everything can be visible through a section called as ACC monitor. Yeah, I will be getting to that point when we start our session for the lab for the GUI walkthrough.
Fine, sir. Thank you.
Okay, coming back to the zero-day deployment. So the default IP address would be 192.168.1.1/24. So this will be the built-in default IP address on the firewall, right? And if required, you could connect your management interface directly. This is a management interface IP, by the way. So you will have a dedicated management interface on your firewall, on all the models of your firewall. So you could take the CLI access If required, you could configure your management IP address to something else and connect your firewall. If there is already an existing network where, for example, your users are connected to the access switch, ASW, to the core, and your legacy firewall, maybe you're replacing this with the NextGen firewall, you could probably connect this management interface that you configured with the IP address of your management VLAN on the network. So all of your devices in the existing network will have a management VLAN. You could connect them, connect the management IP address you've configured, same as the VLAN network as you have in the current network environment. So you could configure them and then connect the management interface to your core switch and configure an access port here on the management VLAN, and you'll be able to access the firewall from remote location through CLI and GUI directly. So this is one way of doing it. Another way of doing it is, since you already have a management interface IP of 1.1, you could configure this computer as 1.2 and access the firewall's GUI through this computer because they are on the same network. They're directly connected. You connect a cable to the management interface, not the console this time, right? Connect a management interface and use the same default IP address of your computer, of your firewall management interface, and configure an IP address in the same network, 1.2, for example, and access the management interface of the firewall through the computer that the local ID is connected. And from here, you can ask him to share your screen, and then access the GUI and CLI through this computer. So one way is using the default IP address and connecting a local cable, direct cable to your local machine, available at the location. Another, changing the management IP address according to the management VLAN and connecting them to the core switch on the access port of the management VLAN and taking the remote access of the device. So these are two ways in which you can get access to the device, especially GUI, and then start configuring your device, right? So any questions here on how the zero-day deployment works, and how do you actually get access to the firewall? Because without accessing your firewall, you won't be able to configure anything. So it's impossible, or it's very difficult for you to configure them through CLI, through the console access. So the first thing you should do is to somehow get the GUI access either through the local IT or by configuring an IP address on the same VLAN as the management VLAN and connecting them to the core switch on the management VLAN access port. So either of these two methods should be followed, and you should be able to get access to your firewall GUI for you to start configuring the firewall. Yeah. So as I mentioned, it's the best practice is to actually do it through the by configuring a management IP address, management interface of the firewall on the management VLAN IP and connecting them to the core. This is the best practice. The reason is you need internet access. As I mentioned yesterday, there was some question asked to me. You need internet access to the firewall for you to download anything. For example, activate licenses on your firewall, device certificate, right? Download software for upgrading them to the latest version, download from cloud, activating dynamic updates, antivirus updates, URL filtering updates, etc. So all of this activity cannot be performed, or you should be performing them in a legacy way by downloading the file, importing it onto the firewall through FTP or whatever. It's going to be pretty difficult. But if you have internet access to your firewall's management interface, you'll be able to achieve all of this in one click. Activating licenses, device certificate, software download from the cloud for you to upgrade the software, activating dynamic updates. Everything can be performed if you have internet access to the firewall. So for you to have internet access to the firewall, the best practice is to actually connect your firewall in the management network of your existing network, management VLAN of the existing network, so that that VLAN is already going to have internet access and your firewall is also going to have internet access. So as I mentioned, your firewall in that case is nothing but a host when you consider a management interface. right? It's just a user getting an IP address and then connecting to internet, right? Any questions here?
This zero-day deployment, you are telling this on-premises firewall or a cloud-based installation firewall? Hello?
Yeah, sorry, can you come again with the question?
No, you are telling this zero-day deployment. Is this zero-day deployment is related on-premises basis firewall or this cloud-based configuration firewall?
No. I just was giving you an example of how do you access the firewall. It's not just if it's a cloud firewall. I'm not. I'm talking about physically accessing the device. Yeah. So if it's a cloud firewall, we are not going to physically rack the device, access them, and then
Because
connect the console cable, etc.
nowadays, many organizations are occupied the cloud-based firewalls only because this on-premises is headache, this maintenance, selected separate server room and all. So multiple organizations are deploying this cloud-based. That's why there is a in syllabus it will be cover this cloud-based installations and anything.
So, when you are talking about deploying your firewall on your
Hmm.
office location, enterprise office location, you will not
Hmm.
be doing for a cloud-based firewall. It's a complex, it's going to be a complex design because your cloud-based firewall means you'll be deploying the firewall in any of the cloud providers environment, AWS or Azure or
Hmm.
any cloud environment. So if you are located in your office and for security analysis for your enterprise security, if your traffic is going from your office location to the cloud and then gets the security done and then goes to internet, you see, it's not going to be a good design because unnecessarily, not unnecessarily, but you will be on your office network here, you'll be sitting here,
Hmm.
you will not be having your firewall in the local network, right? You'll not be having a firewall in the local network, but for the security perspective, for you to make sure that your networks for your computers are actually before reaching internet, they are being investigated by the firewall for any viruses, threats, etc. If you are taking your traffic to the cloud, checking for all the security aspects, and then taking to internet, unnecessarily you are taking a longer path, which will definitely induce latency, right? So it's always important for you to keep your um, security posture inside your office environment, right? Or go with a SaaS deployment.
Okay.
So meaning not SaaS deployment, I'm sorry, SASE deployment. So SASE deployment means you will be having your SD-WAN router on
Hmm.
the local location, and then for security, you will be going to the cloud security
Yeah.
perspective, right?
That's.
So if you're
Hmm.
having your next-gen firewall,
Hmm.
you either will be having a physical device. If you think physical device is taking a lot of space, if
Hmm.
you have any VMware that is deployed already in your location, you can deploy a VM-based firewall. Inside the VMware, connect them to a different network, and do the architecture however you want, right? But
Okay.
if you are going to have the security in-house, you got to be having either a physical device or a VM-based device. Your cloud-based firewall, let me tell you when it is used since this question came up. You will have your enterprise network here, your switch, your firewall, some legacy firewall here. You will have an IPsec VPN, and you will have your AWS environment here. Let's say you are having your resources, servers, etc. deployed inside the AWS environment, inside the private network, private AWS network. For the AWS private servers to come out to internet, you need a firewall here for security. So this will be a cloud-based firewall. Or for your private AWS servers, AWS deployed servers to go through the IPsec VPN. You need a firewall here for security. What exactly are they accessing, especially for internet-based traffic? Because this is already an IPsec tunnel, so it will be secure. So these are the cases where you will be using a cloud-based firewall. Otherwise, if you're using a cloud-based firewall for your enterprise security, you will unnecessarily dealing with reaching from your enterprise network to your cloud for just for the security posture, even for the users to reach internet. That's sort of a longer path you take, right? So if you think getting a physical device is a problem, if you don't have a rack space, etc., you probably should plan your network in such a way that you have a VMware ESXi host, and inside that you should probably deploy servers, firewalls, etc., and then design your network accordingly.
Okay. And one more questions. This nowadays, next generation SIM, some EDI solutions also is there, like a CrowdStrike, a Sentinel-1, or a Microsoft Defender. In that
Mhm.
platform also, they are giving the some option, this firewall settings and firewall configuration related. What is the difference that firewall and this firewall?
Okay, so those tools are probably going to be centric to end host monitoring or end host security, endpoint security.
Yeah, I understand that, but
Mhm.
there is a one options also giving. There is a one platform also is giving that firewall options on platform, and that I see in there we can manage and we can configure there also, right?
See, yeah, see, there will be all competitors coming in and saying that I can do everything. See, CrowdStrike is a competitor. It's a vendor. Firewall, Palo
Mm,
Alto is a vendor. FortiGate is a vendor. Everyone will come back and come and say that my product is going to do everything. But if you look at it from the architecture perspective, your one
mm,
firewall, one device, this Palo Alto Firewall will be able to do DHCP, will be able to do DNS proxy, will be able to do SSL decryption. It's going to be able to do all the security, antivirus, anti-malware, anti-spyware updates, etc. And it is going to be able to do route manipulation in advanced manner, which probably might not be available with CrowdStrike. So your enterprises might be looking at one device, which could probably
mm.
satisfy everything that your company might need. If you're deploying CrowdStrike, there will be a lot of limitations. That's the reason why still CrowdStrike is used for what it is used for, endpoint security, right?
Okay,
So people will come up with ideas from on their product to say that my product will do everything that you need in an enterprise network, but how efficiently they do it is the question. So if
mm.
you see uh, less than 1% of people will be replacing your CrowdStrike device EDR with your Palo Alto firewall or any other firewall. The reason is your firewall can do much more than what your EDR could do in terms of complete package as to how it needs to operate an enterprise network based on routing, based on a lot of features. You have something called as a service route, especially legacy routing, path manipulation, security, everything combined is a package that we are having here as a Palo Alto firewall. But your EDR probably will not be able to do that. I'm not a
Okay.
expert in EDR,
Understood.
but this is one of the main reasons why we don't actually replace a firewall. You cannot think of replacing a next-gen firewall with an EDR. Probably, if you're
Yeah.
replacing next-gen firewall, you'll be replacing them with a SASE architecture, where you'll be
Mhm.
having no firewall at your location, but only SD-WAN routers, and your security will all be moved to the cloud, either Prisma Access or Zscaler, ZIA, etc. Right?
Okay. Yeah, yeah, understood this point. Thank you.
Yeah. Okay. So I hope that there is enough clarity with respect to how your hero deployment is done and why we are talking about it. I'm talking about it in the perspective of a physical device, but as the question arised, if you want to have a VM based deployment, then you should be going for an ESXi host within which you can deploy Palo Alto VM and then run your firewall inside it. Or if you are involving a cloud infrastructure with your enterprise network, Then you can configure your cloud-based firewall on the cloud infrastructure for the cloud resources to reach internet and for them to reach the enterprise network, right? Okay.
Yes.
Yeah. Any questions so far? The important takeaway here is how do you basically access your firewall when it is brand new. When you get the firewall out of the box, one way of accessing it is through console, and then first thing is connecting the management interface directly to a computer and configure an IP address same as this subnet. This is the default IP address of the management network, and taking the access of GUI directly, or configuring the IP address of management interface same as the management VLAN, connecting them to the core, and then accessing them remotely, right? The best practice we said is through the management VLAN, because there are two things. You don't really need your local ID support after this, after the connection is done. And you will be having internet access to the firewall right after you do the IP address change and then connect them to the management VLAN, which is required for you to activate all the licenses, set device certificate, etc. Right? Okay. So if you're good here, let's then move forward with packet flow of Palo Alto Firewall. So basically, when you have a firewall, right from the point where it takes in the traffic and then lets it out from the incoming interface and then lets it out through the outgoing interface, what is the exact flow that you should think of that the firewall would perform is what we're going to look at right now. So basically, there are about 5 stages in this process: ingress and egress, the first and last stage. And in between, you have slow path stage, fast path stage, app ID, and content ID. So these are the stages that a firewall goes through before it takes in the traffic and then lets it out through the outgoing interface. Okay. So instead of looking at it in a blackboard here, where I'll be writing down all of this on what it does, you can probably take a look at this from the official website of Palo Alto. So there are two main websites that you need to be aware of when you talk about Palo Alto Firewall. One is knowledge base. This will probably be this is the article that your TAC engineers, that your Palo Alto vendors probably would be giving you or writing for your information. And these are official documentation: docs.paloaltonetworks.com and knowledgebase.paloaltonetworks.com. So these are the two go-to information that you need to know, that you need to have for you to refer any documentation. So unlike other vendors, your Palo Alto documentation is going to be very crisp and to the point type of documentation. You can probably 100% rely on that. You will not have a lot of information to go through, especially when you're in a troubleshooting phase. You need one line or two line of information as to what you're looking for. So that's exactly what your Palo Alto docs would give you. So this is a knowledge-based documentation. Over here, you will be able to search for any information you want related to the configuration, related to the design, related to any sort of theory, explanation, etc. So this is the diagram, that flowchart that we'll be looking at. We will be going over this flow in brief, not in detail. I will be talking about this flow in detail in the upcoming session. or probably today, we'll be talking about them in short as to what they exactly do, for you to just quickly understand what each phase is for, right? As I mentioned, you have your ingress stage and egress stage as the first and last stage of your packet flow process. You have session setup stage, there is slow path and your fast path, and then you have content ID and application ID. Okay, so just to give you a brief about what exactly each of them do, let me go to the blackboard once to just write down in one line as to what they do. This is to gather, ingress is to gather basic information about your traffic, layer 2, layer 3, layer 4. Egress is to implement QoS, decrypt if there is anything encrypted on the ingress stage, and then let the traffic outside. Look at the outgoing interface and then let it out. So these are the two first and last stages that you will come across in the Palo Alto's packet flow. First ingress stage is gathering basic information. Egress stage is QoS decryption if there is any encryption done on the previous stages here. Slow path is basically for session setup. So if the firewall is receiving a traffic, which, as I said, your firewall made in a session table earlier to keep track of the sessions. If the traffic received is a new traffic, which is not seen by the session table, it's not part of the session table, then it's considered as a new traffic. So the firewall is going to go through the slow path and build a session by gathering some basic information, like what is a NAT, if the NAT is applicable, what's the security policy, if it is matching the traffic, etc. It'll go through some checks and it'll probably form a session setup in this slow path. So if the session is already identified, let's say, for example, I've accessed youtube.com from my computer about 2 hours ago or 1 hour ago. youtube.com is HTTPS based traffic. I know that the timeout value for by default for for a TCP based protocol is 24 hours if I'm not wrong. So hence 2 hours before when I accessed this youtube.com, the session would have been identified by the firewall or created by the firewall. If the session is again available, still available on the firewall will not go through the slow path, right? The firewall will not go through the slow path because the session is already available. The purpose of slow path is just to form a session, create a session on the session table. But if there is a session already for the traffic that I'm sending from this IP address to youtube.com for protocol HTTPS port number 443, etc. If the session is already there on the session table for the exact same traffic, source destination, there is no purpose of slow path. So slow path will be skipped and we'll go to fast path directly. Fast path, on the other hand, it's basically used for implementing a few things. Fast path is basically used for implementing the NAT. So in the slow path, it identified whether the NAT is applicable or not. In the fast path, it's going to implement NAT. And much more. Decryption, if it wants to do SSL decryption, etc., it'll be decrypting the traffic for SSL through fast path. Then app ID. As I said, app ID is for identifying the end application of the user. End user application. It does that using some application signatures, identifies the application, and then checks across the security policy if the application is allowed on the firewall. And then the content ID is basically security profiles, the antivirus profile, anti-spyware profiles, file blocking profile, all the security, next-gen security profiles will be configured and checked across. If the traffic is identified to be a threat or is considered as a virus-based traffic, then it will take actions based on the security profile, whether we have asked them to block it, deny it, or warn them, and then allow, warn plus allow if they are okay. So there are different ways of handling a security profile according to the type of traffic. So based on the security profile configuration, the decisions will be taken on the content ID section here, right? And then the egress stage, it probably will be doing a QoS, if applicable, if the configuration is done on the outside interface going to the ISP. If there's a QoS shaping done, it'll implement that. And if there is any decryption done at the earlier stages, it will again re-encrypt the traffic and send the traffic outside. So these are the basic stuff that your firewall probably does before it takes in the traffic and lets it out. So first and foremost thing is ingress stage. As I mentioned, it basically extracts some basic information L2, L3, L4, and checks for errors. And if it's an IPsec based traffic, it is going to decrypt the IPsec tunnel and get the inside IP header of the IPsec tunnel and then do the process again. Then come to this fast path where it will check for the session lookup of the traffic that you are handling right now. If the session is already available, it proceeds forward with the fast path. If not, it's going to go through the slow path where it checks for the routing forwarding lookup to know the outside interface. It checks for the NAT policy lookup. It checks the firewall policy if it is allowed with the application any, because you see the application identification is happening here. So at this point where it checks the security policy, it doesn't know what application the user is using. So it keeps application as any and checks the security policy across all the other parameters like source IP, destination IP, source zone, destination zone, protocol, port number, etc. It doesn't include application in the security policy check here. And then if there is a loon match, it then creates a session. So the main important stuff in the session lookup, the slow path is session creation. The important stuff that happens in the fast path is NAT. It's going to perform the NAT here. And if there is any decryption applicable, if you have a decryption policy specified for decrypting the SSL traffic, then you decrypt the traffic. And then here, the application identification, pattern-based application identification. It identifies the application based on the application patterns, the signatures, and then checks for the security policy if the application is allowed or not. Parallelly, these two happens in parallel. The app ID, application identification, and content inspection both happens in parallel. Content inspection, on the other hand, it will apply the security profiles and the actions that we have selected in the security profiles as to if it is a virus-based traffic, what action you should take. If it's a normal traffic, what action you should take, allow or deny or block or alert, etc. Right? Here is where your SSL decryption, if it is happening, we will be re-encrypting the traffic if the SSL decryption is applicable. And then to the egress stage, it does QoS shaping, fragmentation, if applicable. So when will you do fragmentation here? So if the next device from the firewall is only capable of receiving so much of traffic. So you have a firewall here. When the traffic is sent out to the next device, probably a router. Let's say you have 1 GB of data to be sent. If the next device is not capable of receiving all the 1 GB of data at once, you will fragment the data into blocks. and then send them as 200 MB as 5 chunks. So that's the reason you do fragmentation when you send the traffic outside of any device. The same applies when the receiving device, when the traffic is received by the firewall at the initial stage. The firewall, if you just recall here, the firewall must have done fragment reassembly because the previous device might have done some fragmentation and sent the traffic to the firewall, and the data would have been received on the firewall as a chunk, as 5 different chunks, 200 MB into 5. The firewall will reassemble the traffic based on the sequence number. So when receiving the traffic, if the fragmentation has been done, it will reassemble it. While sending the traffic out, if required, fragmentation will happen. Along with that, QoS shaping, if there is anything applicable. And then earlier, if you remember, we have done, if it's an SSL traffic, we might have decrypted the tunnel information to get the inside header. We will have to re-encrypt it again and then send the traffic outside. Right? So this is in short about what exactly happens in a firewall's packet flow. Important point to note on what exactly each of these stages do. Ingress stage just collects basic information, encrypts some traffic if required, if it's an IPsec traffic. Egress does QoS, defragmentation, etc., and re-encrypts the IPsec traffic if it's an IPsec traffic. Slow path is just used for session setup. Fast path is used for implementing NAT decryption. Application ID used to identify the application of the user, what application he's accessing. Content ID is basically to verify the traffic against any virus or spyware, malware, etc., and then take decisions based on security profiles, right? So it's not really required for you to go through everything. Just to understand what each of the stages do. When you get into troubleshooting, you probably need to know which happens first, which happens next. For example, the NAT policy lookup happens here. The firewall lookup happens here. But the NAT implementation happens over here in the fast path. Right? So if you want to know which one happens first and next, you can probably come here and take a look at it deeper to understand so that you could troubleshoot it better. But on the outset, it's important for you to just understand what each of these stages do in one line. Ingress, slow path, fast path, app ID, content ID, and egress. Right? Any questions on this one? I hope the baseline is clear as to what each of the stages do. That's what is very important because as we progress along the NAT section, we will come to know, as we progress along the next section, we will come to know what exactly this a specific section is doing because you see they're talking about something called as if destination NAT is present, we are doing something else. If it is a destination NAT traffic, we are doing something else. So we are keeping the application as any here because we do not know what's the application because the application ID is happening over here somewhere outside. So these are some particular information you need to be aware of, but you will get to this when we, do our labs based on the specific topic. But I hope the essence of this is understood. The purpose of each stage is understood in one line. If there is any questions, please do let me know. Are we good,
Sir,
everyone?
hello, am I audible, sir?
Yes, yes, yeah.
Sir, if I just want to, if I do have a IT infrastructure with 500 users,
Mhm.
and how could I differentiate between the different brands like Palo Alto, Sophos, and FortiGate? I mean, which should I prefer? What are the parameter to compare all these?
Okay, so that is the
Because
next topic that I was about to consider to talk about. So see, you don't really think about it technically in terms of performance, in terms of cost, in terms of service is what your business will think about. So end of the day, your enterprise network, your business should get sufficient security on the network with some reduced cost if possible. So Palo Alto is the leader in the security market. So most of it depends upon how your enterprise wants to go with. So something called as Magic Quadrant, right?
Yes, sir.
So in the Magic Quadrant, first things first, your enterprise network business will basically go and take a look at the Magic Quadrant, look who are the leaders. Obviously, Palo Alto will be a leader, Fortinet will be a leader. Second thing, they'll get about 4 to 5 products, 4 to 5 vendors to choose from. You see SASE platform. Gartner says Palo Alto is the leader, right? SASE, as you know, is a combination of SD-WAN and the Prisma access solution that is offered by Palo Alto. So for each of I think over here, you might have, I think this is not NextGen firewall. It says some hybrid mesh firewall, but I don't know where do I get the NextGen firewalls from. If the company is more concerned towards security and the future deployments, there is one thing that Palo Alto Firewall takes an edge is it's the only product that has a complete SASE product coverage, which means uh, Palo Alto is the only product which has an SD-WAN product and a cloud security product that is SSE. So if you consider Fortinet, a Fortinet firewall, it has an in-house next-gen firewall. As you know, SASE is basically the replacement for your in-house next-gen firewall that we are talking about. So if you are looking at SASE for your future, probably 5 years down the line or 10 years down the line, you will probably go for Palo Alto. The reason being, if you consider SASE, it's a combination of SD-WAN and cloud security, right? Palo Alto is the only product that provides both of these services at the moment. If you consider Fortinet, it provides SD-WAN feature, but for cloud security, you will have to go for some other product, probably Zscaler or Palo Alto or anything else. So if you are moving towards SASE architecture, and if your company is concerned towards security a lot, they will probably be aiming to have uniformity in their vendor engagement, right? So in that case, Palo Alto is the only product that they are without a doubt they will be going for. The reason is that's the only product which offers both SD-WAN and cloud security in a single umbrella. Your Fortinet only offers SD-WAN. It doesn't offer cloud security because so for cloud security you need to go for some other vendor if you want to achieve SASE. So in that means Palo Alto is the product that people will go for. In terms of services, the customer service, Palo Alto takes a lead. And in terms of the firewall performance, again, the firewall basically takes a lead. So if you have a Fortinet, for example, it gives you a lot of stuff inside it. It gives you 40 switch, 40 access point. So if you want to have, if you're contented with having a next-gen firewall and then having all your 40 access point, 40 switch, etc. inside a single device, if you're not going for SASE, SASE is not your future for your organization, then you can go for Fortinet. But if you're looking at 5 to 10 years down the line, Palo Alto is the product for you. So just because the performance is slightly better, customer service is slightly better, the responses are slightly, in my experience, is slightly better because I worked with both the products. And more importantly, the future technology, SASE technology, Palo Alto is the only product that offers both SD-WAN and cloud security. Fortinet, I'm not sure if they're cooking something better, but as of now, they only have an SD-WAN product. They do not have a cloud security product. So there are different ways the companies would approach this to take a decision. There is no one straight answer, but these are different aspects that they might think of to decide whether they should go for Fortinet or Palo Alto or any other vendor. Mostly, if they consider future, they'll go for Palo Alto. If they consider one device which gives everything in a single plate, like 40 switch, 40 access point, then probably Fortinet. Only security, then yes, Palo Alto. I hope that answers your question.
Thank you, sir. I got it.
Yeah. All right, guys. I think we are good for today. Just heads up that from next week, as we are going to have a Saturday, Sunday session from next week, we will be connecting extended for an extended period, probably for 3 hours. We definitely will have a break in the middle for like 10-15 minutes for us to get refreshed and come back. But we'll have a 3 hours of session minimum from next week. So the session would probably be starting earlier than 11 a.m. India time. So I will be intimating you guys, or the management will be intimating on the timings in the midweek before Wednesday probably, so that we can get prepared for the next week's session. So from next week, it'll be sort of a collective session for 3 hours, so that we can cover up a good amount of content in a week, so that you will have the remaining 5 days, Monday to Friday, for you to go through a lot of content and come back on Saturday again. Right?
Hello, sir.
Yeah.
Hello. Am I audible? Am I audible, sir? Sir, I have one out of context question actually, though you are an expert on this networking and firewall. There is always the question arise when I am planning for my network infrastructure. Should I prefer the fiber optic media converter or the modular fiber optic modular, which would be preferable? Because if we compare, the modular's price is almost 10 times higher than a media converter. Then what is the benefits of? Actually, I just tried on the internet as well. I just contacted few other vendors, but nobody can give me one clear question answer about this. They only says that it will affect the performance, but I don't get it clearly, sir.
See, when you are talking about a media converter, the name itself says if you don't have a compatible port that satisfies what cable you have, that's when you go for a media converter. So let's say, for example, you have a fiber connectivity provision on your firewall, but the device you're connecting to on the opposite side doesn't have a fiber. That's when you go for a media converter, right? So you will be
Right,
converting
sir.
fiber into RJ45. Obviously, RJ45 is going to give you less speeds, less distance to travel. So definitely it will affect performance. But if you are designing a proper architecture for a seamless experience for your users, then the recommendation is not to use any media converters, especially on the core, on the perimeter edge, right? Your firewalls are perimeter edge devices. So you should be using fiber optic connectivities, or to the least copper to copper, that is RJ45 to RJ45, not using a media converter. So media converters are going to be useful probably towards the um, end devices side of it if you require them. But on the edge, definitely you probably will not have to use media converters, just because it will affect performance. Because if you see, fiber optics are capable of traveling the cables can probably travel a longer distance, give you higher speeds. Your copper cables is going to relatively travel only shorter distance and give you low speeds. So if you're using them, mixing them up inside a media converter, on one end of the side you're using fiber optics, other end you're using copper, then it's definitely going to impact performance. So yeah, it should be either fiber or it should be either copper. So it should not be a mix of both, which will definitely impact performance, especially not at the edge, at the perimeter edge, where you're connecting your ISPs, not at the core. You probably can, if there is no way that you could achieve the connectivity. If the media converter is the only way in certain circumstances, then your media converters can be probably used in the end devices side of it, but not on the core. Core always uh, have to be having a standard, should have a standard. If you're using a fiber optic, on the other side of the cable also should be a fiber optic. If you're using copper, then also it should be copper on the other side too.
Okay,
Is
thank you so much, sir.
that,
Got it. It's clear now, sir. It's clear
okay,
now.
okay,
Thank you. Thank you so much, sir.
thanks. Okay, guys, I think that is it from my side for today. As I mentioned, your next week's schedule, the time that when we are starting, everything will be intimated in the midweek. I hope we will be having a, a group in WhatsApp or any other platform that we can communicate with, where I'll be intimating or the management would be intimating you on the timings of the next week's session. So hope to see you there. I hope today's session was informative. We shall continue next week, probably with everyone else here on the session. So next week again, I will be going over the firewall GUI walkthrough to start with, and then we'll be configuring the management IP address. How do you do it? And then we'll be getting slowly into the core concepts of the firewall.
Thank you.
Right. That's it from my side today. Let's connect next week, and the timings will be intimated in a couple of days from my side or from the management. Yeah. Thanks a lot, guys. Thanks for the time. We'll see you on next Saturday.